Ladies and gentlemen, welcome to Organic Chemistry 1. We're going to look at what we call conformations today. And what does conformation mean in organic chemistry? Well, it means how does a molecule look at a certain time. We have to keep in mind that these sigma bonds that we looked at the other day, they're constantly rotating. So if I have a simple toy here, and we got a toy here, this bond between the purple and the black, constantly rotating. And similarly for every other bond, constant rotation there, and there, and there, and I think you have the idea. So there's different stabilities in molecules where there's not just 5 atoms, such as this one. Yeah, right here. Oh my goodness. We have a toy, and I'm holding on to a methyl. And I think when you look at your quiz, the methyl's straight up. Am I correct? And the hydrogen on the next carbon is straight down. I'm holding that now. Yeah. And away from you on carbon number 5, 1, 2, 3. Oh, 1, 2, 3, 4. I think it's carbon 4 on this toy. I may have made the wrong toy. I may need to add a carbon there, but the idea is right. There's this methyl. And what I want you to do, if we look at the quiz, and we will do that now, or the activity, sorry. This is the molecule, and yes, my assessment was correct. We need a new CH2 here. I'm playing with the toy off screen. And I think I just need to add that. Sorry about that. And now it's C5. So we're asked to put this carbon in front, which really means if you translate the words at the top of the screen, you have to place your eye somewhere and look at this molecule in this question, which you will see on test 1. And you are told you have to be looking right along here. That's what those words mean when it says put C number 5 in front and C number 6 behind. And I will do a lame attempt at putting an eye here. I don't know, maybe a little eyelash here. There's your eyeball, a hairy eyeball looking at carbon 5. And what you get when you do that is you see carbon 5 as a ball, a perfect sphere. Oh, look at that, that's cheating. And we're always going to be looking at a carbon in front in all 3 examples. And that's all you see from that. Now, you do see the 3 bonds sticking off of it. You do not need a toy to do this. And I know we had a big discussion the other day about, I don't expect you to have spatially gifted abilities at looking at things. So follow my system here from a guy that doesn't have spatial abilities either. And if you can get down on this page, what we're looking at here, then you've overcome your disability, which is cool. Now, the bond I like to draw first, of these 3 things I'm going to draw, methyl, iso 1, 2, 3, 4, 5 pentyl, and 1 bromo ethyl. Of those three things, I'm going to draw this one first for a very simple reason. It's the one that's not a wedge or a dash. We agree, right? That means it's either straight above your eye or straight below your eye. There's only 2 choices. And I think you know the answer. It's right on the screen. You're going to draw a bond to the methyl straight up. That's the bond you should draw first. Little guide here. You're doing blue first as a strategy on this question. You don't have to use my strategy. If you find a strategy that works better for you, please do it. And that means I'm going to draw this bond first. And it's the end of a stick. It should be straight up. I'm trying my best. I'm going to stop using the straightening tool because that's not really fair. So that's the methyl right there. And then I'm going to go to carbon 6 because there's a bond off carbon 6 that's not a wedge and not a dash either. 6 is the invisible carbon in this question because 5 is right in front of your face. You don't see 6. If you were an astronomer, you'd use the word eclipsing, wouldn't you? We'll talk about eclipsing more later. But right now you don't see 6, but you can see the bond sticking off of 6. That H is the one I'm going to draw. Off of 6, I'm going to draw this first. Why? Because it's not a wedge or a dash. Is it above my eye or below my eye? It's below. Draw it straight down. Draw it in blue so you remember that was the first thing you did. Now, when you have a bond off the back carbon, you don't see the whole bond because, you know, the front carbon's in the way. So that's how you show bonds off the back carbon. They end at the ball. They're not attached to the ball, which is carbon 5. They're attached to what's behind the ball. What's behind the ball? Give me a number. Carbon 6. You were told it has to be behind the ball. Okay, so blue's first, blue's done. And then the question is, and this is going to get a little funky. This bond here, I got 2 questions about it. Start with the easy one. Is it away from you or towards you? It's towards you. Now, when you're standing over there, which I'm going to do, and I'm going to try to rotate our camera. It's going to look pretty strange on this video, but I think it will get the point across. I gotta be, oh, this is hard. Seeing that molecule, and I'm not that tall. I'm going to steal a chair. Can I steal a chair? Okay, I'm going over there. You ready? I'm putting myself where my eye has to be. I am exactly where my eye is supposed to be, right? And you told me this group here is sticking towards you. Which hand did I just use? I don't know if the microphone's that sensitive. That was my right hand. Make sure you draw it to the right. Make sure you draw it a little down because it's below your eye. Don't draw it straight down. It's not straight down. Straight down would be in between those 2 things. Okay, right hand for that group. I'm going to go draw it. And hi, I'm back. And we'll do that in red. You said right hand and slightly down. CH2 once, CH2 twice. Wow. CH2 once, CH2 twice, and then ethyl. There's the red. Just circle it in red. You don't have to do that on your quiz, but for your activity. Are you going to make me run all over there again and use my left hand to grab this group, or are you going to just trust me on that? If I was using my right hand to go out in front of the screen, it's got to be my left hand to go behind the screen, right? Okay. So I'm going to draw a CHBr, CH3 slightly down. Please don't draw it straight down. It's not. Slightly down and to my left. And we'll do that one in, let's use all the colors we can. Green, slightly down to my left. They're evenly spaced if you need a little help. See those 3 things I drew on the front carbon? I just drew 3 bonds. One's blue, one's green, one's red. Notice they're evenly spaced. This is Vseper, right? Cannot be violated. I'm not going to run over to the screen again. Remember when it was a wedge, it was to my right? Do you remember that? Well, doesn't that make this to my right as well? It's on the same side of the molecule. Now, you're going to draw it to your right. And what? A little up or a little down? Up. So I'm going to go CH2 once, twice, 3 times, and then ethyl. And we'll do that in orange. To my right, a little up. CH2 once, twice, CH, ethyl, right there. And that was to my right. Oh, is that the one to my right? CH2 once, twice, and a C with the ethyls. Yeah. And what about this guy here? Dashes, if I'm standing over there again, where it's to my left. And a little above my eye, clearly, right? And it's pink. CH2 once, then a C with a V. It's not really a V, it's diethyl. Congratulations, that's 3 points. With practice, you get better at this too. And just a reminder, you don't have to put this on your activity, but there's 5, there's 4, there's 3, 2, 1, and behind is 6, right? You don't see 6, but you do see 7, 8, 9, 10, 11. You've done all the hard work on this problem right now. The hard work's in the first one. Everything else is just rotating. But we have to introduce a new word, and the new word is bulky. When we're talking about the word bulky, we're talking about a concept called steric hindrance. Okay? What is steric hindrance? Well, it's quite simple. When objects get close in space, that's steric hindrance. We don't like objects close in space, right? There's repulsion. So, I have 2 simple objects here. If I got 2 things like this real close together and I'm trying to get in between them with my pen, that's quite a bit of steric hindrance. If it comes in from an angle there, it's hitting the blue. Angle here, it's in the pink. And the only way, there. Less steric hindrance, hey, if the things were further apart, right? Things further apart, easy to get in there. More attack angles to get in between. Less steric hindrance, more steric hindrance. Okay? Now, with the word bulky, the question you need to ask yourself, what is the bulkiest group on the front carbon? That's carbon 5. And what is the bulkiest group on the back carbon? That's number 6. I can tell you the least bulky group on carbon 5 is the methyl. It doesn't take up a lot of space, does it? This one, and I don't know, we only have the small picture here. And I think this is best done with the toys. So let's go with the stop share. Now, we're back to the methyl. Methyl here. It's less bulky than this because look, this thing's got these 2 objects here. One's a bromo, one's a methyl, and there's none of that going on with a methyl. It's got 3 H's around it, right? You know I missed the H's. They don't take up much space. So this being branched right here, really close to carbon 5. See, there's a branch. I know one of the branches is a bromo, but that's a big atom, isn't it? Consider it like a methyl group. So that's like a branch near the connection. That's what we call bulky. This doesn't have a branch here. This next group does not have a branch here. I don't think I have the right next group either. Close. Yeah. There. It's even less bulky than it was before. Oh, it does have a branch. Do I have the right group? I gotta look at my question now. When you're in a hurry, getting ready for class. The group I'm holding is supposed to be a CH2 once, twice. That's the hydrogen. That's the one on the hydrogen card. CH2, no, it's yeah. I'm sorry. Back to the picture. We're sharing. Stop and share. We got methyl down here, not bulky. Not bulky, hard to see here because it's a toy, but look, it's just a CH3. This one we determined to be bulky because it had the branch, right? Branch. This one here, it's bulky. This other one we haven't looked at yet. It's straight in the air. But that's a CH2 that doesn't have a branch. It just has one more C. There's no branch right there. So this over here that we looked at with the bromine is bulkier. CH2, no branch, not bulky. The branch is over here. That means the bulky part can be swung away from where it's getting some hindrance on carbon number 6. Okay? This can swing away from 6. This tries to swing away, and one of the other groups gets near 6. See that? That's what a branch does. You're trying to swing away from carbon 6. Here I go. Oh, but this methyl moved in front of 6, or close to 6. Sorry. You can't get everything away from 6. So when he says bulky from now on, it just means branched close to the groups you're trying to get away from. That's what bulky means, okay? Branched close to the group you're trying to get away from. So back to sharing. And we see that this thing, and we'll just circle bulkiest in baby blue. Bulkiest on C5 was this group where the branch is right away. You see that? It's kind of easy to see it with stick figures. And you tell me on the back carbon where you're comparing this pink group to this orange group to the hydrogen, which one's the most bulky? And if you want to be funny, you can say hydrogen, but don't do that. Which of these two is bulkier? The one that goes CH2, then a C branch? Or CH2 once, twice, then a C branch? I think you know the answer. Go pink, right? So pink is the bulkiest on the back. And I see that those groups, the two circle groups, are not as far apart from each other as possible. Therefore, this is not the most stable conformation. I need to rotate one of the carbons, and I even gave you a hint which one I wanted you to rotate. Rotate carbon 5 to achieve the most stable conformation. How many degrees do I need to rotate it so that the pink group ends up 180 degrees from this bond? Good exercise we should take some time on. No. Do we see that we have a circle and it is divided into 6? Here, watch. Here's the beginning right here. And then 60 degrees there. And then 60 degrees here. And then 60 degrees here. And then 60 degrees here. And then 60, and then you're back to the original. Yes, why did I use 60? Because I just did 6. I had to get to 360 to get back to the original. Yeah. So when we have a molecule drawn like this that has even spacing between front, back, front, back, front, back, it's called, somebody know? Finish the word for me. Saturated? No. Yeah, it is saturated, but that's a different question. Everything evenly spaced. Somebody's trying to say it. Oh, man. Staggered number 1. This will be staggered number 2. Because it'll be, no, I'm going to move this comment over because it's for the second molecule. And we're going to shrink things eventually or move them some more. There we go. And this one's going to be terrible. What does that mean? That means groups are going to be real close to each other. And when that's the case, they'll be eclipsed. And the Newman is a great way to see the difference between staggered and eclipsed. Right now, you're not seeing anything. So I'm going to re-ask my question. How far do you rotate? And I believe I misspoke. I'm supposed to rotate the front carbon. So I'll be rotating this group here, right? And I need to get it over. Why do I have to need to get it where the orange is? Or that's red, sorry. So it's 180 from the pink. I need them straight across. Where this group is now is where this group needs to be. So what is the angle of rotation on the front? Yes, it was 60 to the H and then 60 more to get over there. And then you better rotate that 120 and then you better rotate that 120 because you're doing that, everything, rotate 120. How do you start? Copy the back carbon. Don't rotate it. You were told not to rotate it. I will even use my color scheme. On a test, you probably don't have time to use color schemes. Orange. CH2 once, twice, C with a ethyl V. Now, front carbon, the green rotated to here, Br methyl. The red rotated to the top, CH2 once, C with the diethyl. The pink group rotated, the methyl group, sorry, back carbon, methyl group rotated to here. And that bond, why do we see the whole bond? Because it's on C5, there you go. So we say the dihedral angle, between the bulkiest groups, give me a number. They are straight across from each other. Give me a number. Yeah. That's the definition of the most stable conformation. Right there. In B, you're supposed to draw the most stable conformation. And that, hey, the answer is this. The description of what your goal is there. Yes. Probably. Yeah, I didn't finish drawing my molecule. You can tell Dr. Whitaker likes dimethyls more frequently than diethyls. Yes, she asked why did the pink methyls disappear? And I didn't have an answer for her. Now,
everything appears so easy, but when I go home try and do something myself, I'm like, really?
More practice exams. It starts clicking the fifth one you do. There you go. Now, and to get to the least stable, I need the bulkiest groups right on top of each other. So I'm going to rotate, I'm supposed to rotate the front carbon negative 60 or positive 60, doesn't matter, whatever it is to get it in front of this. Once again, start by copying the back carbon, no rotation. You were told in the question, don't rotate the back carbon, even though those words were not used. Pink is where it was before, CH2C, diethyl, not dimethyl, good. Orange, 2 CH2s, CH2 once, CH2 twice, C, ethyl, ethyl, and copy the H. The pink rotated, the blue is going to rotate in front of the pink. So I think the blue here, it was negative 60, wasn't it? I'm going to rotate the front carbon because the question told me negative 60 there. It puts the methyl right on top of this group. The green got rotated the same amount. And the red got rotated the same amount. CH2 once, C with a diethyl. And you'll see that, wait, did I do that right? I said the bulkiest should be in front. Yeah, that's good practice. I drew the second worst molecule, didn't I? It's good practice. This is not the bulkiest, and it's on top of the bulkiest. I think my first description was positive 60, and I was right. So if you were asked for the second least stable conformation, this is it. On this question, I would give the student 2 out of 3 for at least being able to draw it and rotate it, but they can't get 3 out of 3 because they didn't draw the worst conformation, did they? How many control Z's to get that front carbon naked here? 1, 2, 3, 4. There you go. I'm going to rotate so that the green group's right on top of the pink. Bulkiest on bulkiest. Br methyl. That was negative 60 for that. Methyl went negative 60. And the CH2 red, negative 60 as well. CH2 diethyl. And I apologize for making a mess of your activity, but this is the real final answer because the bulkiest group on the front carbon is this one. And it's right in front of this, which means it's suffering from a great deal of, starts with an S, 2 words, second word with an H. Yes, has the most steric hindrance. Worst steric hindrance with bulkiest groups. What do you call it when a group's right in front of a group? Eclipsed. And the answer that I erased did not have the bulkiest groups eclipsed. It had the bulkiest with a less than bulkiest. Not as bad. Things weren't as close in space.
When was exam 1, Professor?
I don't know. It's on the syllabus though. And here we go. We're going to hit stop and leave this here for you to finish.